Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 23rd sum. Already in the last videos, I have uploaded solutions till 22nd sum. So please do check it. Now we can move on to the 23rd sum. Now find all points of discontinuity of f where f of x equal to sin x by x if x is less than 0. Then x plus 1 if x is greater than or equal to 0. Here they are asking us to check the discontinuity for the f of x throughout the real line. Okay, so here f of x has a two different functions, so throughout the real line we don't have a single function. Now using the if condition, what we need to do is we have to break the real line. Okay, so let's do it and we'll see how many cases we need here to check the continuity. So using the if condition, at x equal to 0 I am going to break the line. Okay, now here I can see one interval and here I can see the other interval. So this interval is what? Minus infinity to 0, that is if x is less than 0. If x is less than 0, whether any discontinuity is happening or not, I am going to check. Okay, now next I am going to check it for at x equal to 0, whether function is discontinuing at x equal to 0 or not, I am going to check. Now in this interval is what? If x is greater than 0. So at this particular interval, the function is discontinuous or not, I'm going to check. Now to check the continuity for any function at any point, basically we need three stuff. What are those? For suppose if I'm checking for at x equal to 0, I need three things, that is f of 0 value, left hand side close values of the 0. Approximately whatever value we get for f of 0, the same value we have to get. That is what? Left hand limit we need, then right hand limit we need. So if all the three values coincide, then I can say that at x equal to 0, function is function is continuous. Now similarly, if x is less than 0, if x is less than 0 means we have infinite real values lies in this particular interval. So we can have some common name. Let's see be the any real value. At the same time, c should be less than 0. Okay, now f of c is required, then left hand limit of the c, right hand limit of the c, all the three things are required. Then if all three things are matching, if the same thing, then we can say that the function is continuous if x is less than 0. Otherwise, throughout this interval, okay, for this entire interval the function discontinuous. Similarly we are going to say for if x is greater than 0. Okay, now slowly let's start with the each cases. Now case 1, any order we can take it. Now I'm going to take it this one as a case 1 at x equal to 0. So case 1 at x equal to 0. Okay, if x takes the exactly 0, so suitable function from the given f of 0 we need to find first. Suitable function from the given is the second one. Now f of x equal to x plus 1, then f of 0 will be 0 plus 1. Now 0 plus 1 is what? Which is 1. Okay, now left hand limit. So we need three things. Now left hand limit we have to find out. Limit x is approaching to 0 from the left hand side f of x. So suitable f of x left hand side close values are approximately 0. Okay, but they are less than 0. So suitable function from the given is first one, sin x by x. See in grade 11 we have studied some of the standard results for the limits. No, we reached here as a standard result. So limit x is approaching to 0, sin x by x value is 1. For the standard results we no need to give a proof every time. So we can directly write the answer as a 1. Now right hand limit we have to find out. Now limit x is approaching to 0 from right side. Right side close values are greater than 0. If it is greater than 0, from the given what is a suitable function? X plus 1. So now replace f of x as a x plus 1. Now applying the limit, in place of x if you replace 0, it's a 1. Now we can notice that f of 0 value, left hand limit and right hand limit, all the values are same. Now from this we can say that the function is continuous at x equal to 0. Okay, f of x is continuous at x equal to 0. Okay, next for case 2, if x is less than 0. Okay, for this entire interval whether function is continuous or not or it discontinuous, let's check. Okay, now case 2, if x less than 0. If x less than 0 means we have infinite real values lies in this particular range. So we can take it as a C. Let's see be the any value. Let's see be the any real value. Any real value at the same time C is less than 0. Okay. So what are the things are required to check the continuity? F of C, left hand limit, right hand limit. Three things are required. Now let's find out F of C. So what is the condition for the C? C is less than 0. If it is less than 0 from the given, what is a suitable function? Sin x by x. So here our input is C. That means sin C by C we will get. So sin C by C. Okay. So now we need left hand limit and right hand limit. So is it necessary to find out left hand limit, right hand limit separately? Let's check for that one first. See now to the C, left side close values of C are less than 0. Okay, that means while in the process of finding the left hand limit, in place of f of x we are going to use the sin x by x. That function we are going to replace. Okay, now right side close values of the C also less than 0 only. So that means again same function, even while finding the right hand limit also we are going to substitute. So since function is same, it's not necessary to find out left hand limit, right hand limit separately like this. Same function or then same outcome only we are going to get it. So for time saving purpose, instead of finding left hand limit, right hand limit separately, together itself we can find out with no indications. Okay. Now limit x is approaching to the C. If I put minus na, that means left hand limit. If I put plus, it's a right hand limit. If there is a no indication, then it is combine together. Okay, so limit x is approaching to C, f of x. So what is a suitable f of x? F of x is what? Less than 0. If it is a less than 0, then first function, that is sin x by x. So in place of f of x, replace the first function, sin x by x. Now applying the limit, sin C by C. Now what we can say from this, f of C value, now limit x is approaching to C, f of x, both are same, no. So from this what we can conclude, f of x is continuous if x is less than 0. If x less than 0. Now finally we have to check for the other interval as well. Okay, if x is greater than 0, how the function is here, whether it is discontinuous or continuous, we are going to check. If x is greater than 0. Okay, so if x is greater than 0 also, infinite. So here, sorry, one second. Uh, so at 0 we broke the line, here infinite. So let's take in this interval basically we are going to check the continuity. So here infinite real values are lies. So I'm going to have a common. Let's see be the any real value. At the same time C should be greater than 0. Let's see be any real value. At the same time C is greater than 0. Okay, so to check the continuity for at any point we need three things: f of C value, left hand limit and right hand limit. All the three things are required. Now f of C, first I am going to find out f of C. So what is the condition for the C? C is greater than 0. If it is greater than 0, suitable function, second one, that is x plus 1. So if input is C, then C plus 1. Now left side close values of the C, right side close values are C, are both are greater than 0. If it is greater than 0, we are going to use the second function. So instead of finding it left hand limit, right hand limit separately, together itself we can find out. So limit x is approaching to the C, f of x. So suitable f of x is what? X plus 1, because C is greater than 0, no? So x plus 1. Now apply the limit C plus 1. Now from this what we can say? F of C value, limit x is approaching to C, f of x, both are same. So from this what we can say? F of x is continuous if x is greater than 0. Now actually in all the three cases we covered throughout the real line, we check the continuity. So what is the final conclusion that we can have? At x equal to 0, function is continuous. If x is less than 0 also, function is continuous. If x is greater than 0 also, function is continuous. So altogether we can say that the function f of x is continuous throughout the real line. Okay, from above cases we can say that from all cases, what is the final conclusion? F of x is continuous for all real values. Okay, so what is the question is demanding us to find the discontinuity, find all points of discontinuity. They're asking us to at which point the function is getting discontinuous. They're asking us to find out. That means there is a no point of discontinuity here for this given f of x. Okay, and that's all the solution, and thank you for watching, and please do subscribe. Thank you.